Dear students, welcome to Learning Management System, Department of Collegiate and Technical Education. The subject is Analog Electronics, Unit number 2, Transistors and MOSFET. This is the session number 16. Myself, Mohan Kumar MR, lecturer, HMS Polytechnic, Government Aided, Tumkur. The topics that are to be covered in this sessions are construction of N-channel E-MOSFET and operation or working of N-channel E-MOSFET. Before going for today's session, let me have some quick recap of previous session. In previous session, we had a discussion on FET definition, types and its symbols, construction of JFET, MOSFET definition, types and its symbols. We know that FET means field effect transistor, which is having three terminals, gate, drain and source, which is used for amplification or switching purpose. It is a voltage control device, and we have discussed its symbols, and also we have discussed the construction of JFET. JFET means junction field effect transistor, which is having P-type material in N-type substrate and N-type material in P-type substrate. If the number of holes are having majority, then it is said to be P-type JFET. If the number of electrons are more, then it is said to be N-type JFET. MOSFET means metal oxide semiconductor field effect transistor, which is having three terminals. It is gate, drain and source. The metal oxide is isolated the gate to the semiconductor layer of silicon dioxide. This is also used for amplification or switching purpose. The types of MOSFETs are enhancement mode type MOSFET and depletion mode type MOSFET. In that, further it has been classified into N-channel MOSFET and P-channel MOSFETs. This is about previous class. Let me go for today's class, that is construction of N-channel E-MOSFET. E-MOSFET means enhancement mode MOSFET. It consists of two highly doped N region that are diffused into lightly doped P-type substrate. Means in this figure, you're going to see the two highly doped N regions. This is the two highly doped N regions. N plus, it is indicating the highly doped N regions 1 and 2. ಅಂದ್ರೆ ಈ ಫಿಗರ್ ಅಲ್ಲಿ ಎರಡು ಎನ್ ರೀಜನ್ಸ್ ಇರುತ್ತೆ, ಅಂದ್ರೆ ಎನ್ ಪ್ಲಸ್ ರೀಜನ್ಸ್, ಒಂದು ಎನ್ ಪ್ಲಸ್ ರೀಜನ್ ಮತ್ತೆ ಇನ್ನೊಂದು ಎನ್ ಪ್ಲಸ್ ರೀಜನ್ ದಟ್ ಆರ್ ಡಿಫ್ಯೂಸ್ಡ್ ಇಂಟು ಲೈಟ್ಲಿ ಡೋಪ್ಡ್ ಪಿ ಟೈಪ್ ಸಬ್ಸ್ಟ್ರೇಟ್. ಇದು ಪಿ ಟೈಪ್ ಸಬ್ಸ್ಟ್ರೇಟ್. ಇದರಲ್ಲಿ ಡಿಫ್ಯೂಸ್ ಆಗಿರುತ್ತೆ ಈ ಎನ್ ರೀಜನ್, ಎರಡೂ ಎನ್ ರೀಜನ್ ಪಿ ಟೈಪ್ ಸಬ್ಸ್ಟ್ರೇಟ್ ಅಲ್ಲಿ ಡಿಫ್ಯೂಸ್ ಆಗಿರುತ್ತೆ. Second point is the channel between two N region is absent. ಅಂದ್ರೆ ಈ ಎರಡು ರೀಜನ್ ಮಧ್ಯೆ ಇರೋ ಚಾನಲ್ ಆಬ್ಸೆಂಟ್ ಆಗಿದೆ. ಅಂದ್ರೆ ಹಿಯರ್ there is no channel exist in between these two N regions. N regions ಮಧ್ಯೆ ಯಾವುದೇ ಚಾನಲ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಿಲ್ಲ. But the SiO2 layer is present. SiO2 layer is silicon dioxide layer which acts as a dielectric material. ಅಂದ್ರೆ ಸಿಲಿಕಾನ್ ಡೈಆಕ್ಸೈಡ್ ಲೇಯರ್ ಇಲ್ಲಿ ಪ್ರೆಸೆಂಟ್ ಆಗಿರುತ್ತೆ. ಇಲ್ಲಿ ಇನ್ ಬಿಟ್ವೀನ್ ದ ಪಿ ಟೈಪ್ ಸಬ್ಸ್ಟ್ರೇಟ್ ಅಂಡ್ ದಿಸ್ ಎನ್ ರೀಜನ್. ಎನ್ ರೀಜನ್ ಅಂದ್ರೆ ಎನ್ ಟೈಪ್ ಎನ್ ರೀಜನ್ಸ್ ಆರ್ ಡಿಫ್ಯೂಸ್ಡ್ ಇಂಟು lightly doped ಪಿ ಟೈಪ್ ಸಬ್ಸ್ಟ್ರೇಟ್. ಇಲ್ಲಿ ಸಿಲಿಕಾನ್ ಡೈಆಕ್ಸೈಡ್ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಲೇಯರ್ ಪ್ರೆಸೆಂಟ್ ಆಗಿರುತ್ತೆ ಇನ್ ಬಿಟ್ವೀನ್ ದಿಸ್ ಎನ್ ರೀಜನ್ ಅಂಡ್ ಯುವರ್ ಟರ್ಮಿನಲ್ಸ್. ಟರ್ಮಿನಲ್ಸ್ ಮತ್ತೆ ಎನ್ ರೀಜನ್ ಮಧ್ಯೆ ಸಿಲಿಕಾನ್ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಲೇಯರ್ ಇನ್ಸರ್ಟ್ ಮಾಡಿರ್ತಾರೆ. And the third point is the source and drains are taken out through the metallic contacts of n-doped region. ಅಂದ್ರೆ source terminal, ಇದು source terminal, this is called as source terminal and this is called as drain terminal. ಈ source terminal ಮತ್ತೆ drain terminal ನ ಮೆಟಾಲಿಕ್ ಕಾಂಟ್ಯಾಕ್ಟ್ಸ್ ಇಂದ ಆಚೆ ತೆಗೆದಿರ್ತಾರೆ. ಅಂದ್ರೆ this is the metallic contacts from which they are taken out the source and drain terminal. ಮೂರು ಟರ್ಮಿನಲ್ಸ್ ಇರುತ್ತೆ, ಸೋರ್ಸ್ ಟರ್ಮಿನಲ್, ಗೇಟ್ ಟರ್ಮಿನಲ್ ಮತ್ತೆ ಡ್ರೈನ್ ಟರ್ಮಿನಲ್. ಈ ಮೂರು ಟರ್ಮಿನಲ್ ಮೆಟಾಲಿಕ್ ಕಾಂಟ್ಯಾಕ್ಟ್ಸ್ ಇಂದ ಆಚೆ ತೆಗೆದಿರ್ತಾರೆ. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ದ ಮೆಟಲೈಸೇಷನ್ ಲೇಯರ್. ಇದನ್ನ ನಾವು ಮೆಟಲೈಸೇಷನ್ ಲೇಯರ್ ಅಂತ ಕರಿತೀವಿ. ಹೆನ್ಸ್ ದ MOSFET ಇಸ್ ಕಾಲ್ಡ್ ಮೆಟಲ್ ಆಕ್ಸೈಡ್ ಸೆಮಿಕಂಡಕ್ಟರ್ ಫೀಲ್ಡ್ ಎಫೆಕ್ಟ್ ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಅಂತ ಕರಿತೀವಿ. Next we go for operation or working of an eMOSFET. In this figure you can see the voltage between the gate and the source terminal. This voltage is called VGS. VGS andre voltage between gate and source terminal. And also you can see the voltage across the the source and the drain terminal. Andre VDS is the voltage across drain and source terminal. ಇದು VDS ಡ್ರೈನ್ ಮತ್ತೆ ಸೋರ್ಸ್ ಟರ್ಮಿನಲ್ ಮಧ್ಯೆ ಇರುತ್ತೆ. ಸೊ ಅದನ್ನ ಆ ವೋಲ್ಟೇಜ್ ನಾವು VDS ಅಂತ ಕರಿತೀವಿ. ಸೋರ್ಸ್ ಮತ್ತೆ ಗೇಟ್ ಟರ್ಮಿನಲ್ ಮಧ್ಯೆ ಇರೋ ವೋಲ್ಟೇಜ್ ನಾವು VGS ಅಂತ ಕರಿತೀವಿ. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ದ ಮೆಟಲೈಸೇಷನ್ ಲೇಯರ್. ಅಂದ್ರೆ ಇಲ್ಲಿ ಮೆಟಲೈಸೇಷನ್ ಲೇಯರ್ ಅಂತ ಕರಿತೀವಿ. ಆಯ್ತಾ, ಇದು ಗೇಟ್ ಟರ್ಮಿನಲ್ಗೆ ನಾವು ಐಸೋಲೇಟ್ ಮಾಡಿರ್ತೀವಿ ಈ ಮೆಟಲೈಸೇಷನ್ ಲೇಯರ್. This is called the silicon dioxide dielectric layer, which acts as a dielectric material. This is the symbol of eMOSFET, means MOSFET symbol which is having drain, gate and source terminal. Along with this, we are going to have one substrate terminal. If you come for working part, here initially VDS is applied to the source and drain terminal. Means when drain to source voltage is applied by keeping the gate to source voltage 0. Means we have to apply the voltage, that is VDS, for drain to source terminals by keeping this VGS, voltage between gate and source, is 0. We have to apply only the VDS voltage between drain to source voltage by keeping the VGS as 0. After this, by increasing the magnitude of VGS, means the magnitude of VGS, if you increase, means in a positive direction, the concentration of electrons near the SiO2 layer increases. Means if you increase the magnitude of VGS, andre VGS voltage na magnitude na increase ಮಾಡಿದ್ರೆ ಅದು positive direction alli, the concentration of electrons near the SiO2 layer increases. SiO2 layer concentration increase ಆಗುತ್ತೆ. ಸೊ ಅದರಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ ಮೂವ್ಮೆಂಟ್ ಆಗುತ್ತೆ. At particular value of VGS, there is a measurable current flow between drain and source. Andre some value of VGS, there is a measurable current, the measurable current that flow between drain and source. ಈ ಡ್ರೈನ್ ಮತ್ತೆ ಸೋರ್ಸ್ ಟರ್ಮಿನಲ್ ಮಧ್ಯೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ ಯಾವಾಗ ಅಂದ್ರೆ at particular value of VGS. ಅಂದ್ರೆ ನೀವು VGS ನ ಪಾಸಿಟಿವ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಿದ್ದಾಗ ಅಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ವ್ಯಾಲ್ಯೂ ಯಾವುದೋ ಒಂದು ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ಮೆಜರಬಲ್ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ. ಮೆಜರಬಲ್ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ ಯಾವುದ್ರ ಮಧ್ಯೆ ಅಂದ್ರೆ ಡ್ರೈನ್ ಮತ್ತೆ ಸೋರ್ಸ್ ಮಧ್ಯೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ VGS ಇಸ್ ಕಾಲ್ಡ್ ಥ್ರೆಶೋಲ್ಡ್ ವೋಲ್ಟೇಜ್. ಅಂದ್ರೆ ಈ ವ್ಯಾಲ್ಯೂ ಆಫ್ ವೋಲ್ಟೇಜ್ VGS ವ್ಯಾಲ್ಯೂನ ನಾವು ಯಾವ ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ಮೆಜರಬಲ್ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೋ ಆ ವ್ಯಾಲ್ಯೂನ ನಾವು ಥ್ರೆಶೋಲ್ಡ್ ವೋಲ್ಟೇಜ್ ಅಂತ ಕರಿತೀವಿ. ಅಂಡ್ ಇಟ್ ಈಸ್ ಡಿನೋಟೆಡ್ ಬೈ VT. ಅದನ್ನ ನಾವು VT ಅಂತ ಕರಿತೀವಿ. Hence, the conductivity of the channel is enhanced by increasing the VGS to pull more electrons into the channel. If you want to increase the conductivity of the channel to enhance the electrons by increasing the VGS to pull more number of electrons into the channel. ಅಂದ್ರೆ ಇಲ್ಲಿ ಕಂಡಕ್ಟಿವಿಟಿ ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕು, ಎನ್ಹಾನ್ಸ್ ಆಗಬೇಕು ಅಂದ್ರೆ VGS ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ನ ಫರ್ದರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಿದ್ರೆ ಇದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಪುಲ್ ಮಾಡುತ್ತೆ, ಇಲ್ಲಿಗೆ ಚಾನಲ್ಗೆ ಮೋರ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ ಚಾನಲ್ಗೆ ಪುಲ್ ಮಾಡುತ್ತೆ. ಸೊ ಅವಾಗ ಕಂಡಕ್ಟಿವಿಟಿ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಅಂದ್ರೆ ಕಂಡಕ್ಟಿವಿಟಿ ಎನ್ಹಾನ್ಸ್ ಆಗುತ್ತೆ. ಸಿನ್ಸ್ ದ ಚಾನಲ್ ಡಸ್ ನಾಟ್ ಎಕ್ಸಿಸ್ಟ್ ವಿತ್ ದ VGS ಇಸ್ ಈಕ್ವಲ್ ಟು 0. ಅಂದ್ರೆ VGS 0 ಇದ್ದಾಗ there is no channel exist in between these two terminals. ಅಂದ್ರೆ ಡ್ರೈನ್ ಮತ್ತೆ ಸೋರ್ಸ್ ಮಧ್ಯೆ ಯಾವುದೇ ಚಾನಲ್ ಅಂದ್ರೆ ಇಂಡ್ಯೂಸ್ಡ್ ಎನ್ ಚಾನಲ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಲ್ಲ. ಯಾಕಪ್ಪ ಅಂದ್ರೆ VGS 0 ಇರುತ್ತೆ. ಇಫ್ ಯು ಅಪ್ಲೈ ಓನ್ಲಿ VDS, when you apply only VDS by keeping VGS is equal to 0, there is no current that will going to flow from source to drain. There is no movement of electrons in between these two N regions, N highly doped regions. Hence, it is enhanced, means the conductivity which will going to enhance it by application of this positive voltage VGS. By increasing the magnitude of VGS, we are enhancing the current flow in between these two terminals, that is source and drain. Hence, this type of increasing the induced N channel by applying the positive voltage across the VGS, it is said to be called as E-MOSFET. By the application of positive voltage, we are, and by application of positive voltage VGS, we are increasing the voltage. We are increasing the voltage of VGS, and also we are increasing the current flow in between these two N highly doped regions. This type of MOSFET is called enhancement MOSFET. Enhancement MOSFET means it is enhanced due to the application of VGS in a positive direction. The electron movement taking place from one region to one N region to another N region. This type of MOSFET is called as E-MOSFET. Here, the current that will going to appear in between these two is called as output current. That is nothing but your drain current, ID. ID means the output current, drain current, that is current which is flowing in between these two N regions. The source current is equal to drain current because the current which is flowing in this region is same as this region. So the drain current and source current both are same. Hence, ID is equal to IS. ID means drain current, IS means source current. Both the currents are equal because the current flow taking place in between these two terminals. Hence, the current flow is same in both the terminal. This, this is about the construction and working of N-channel E-MOSFET. At the end of this session, the students will be able to understand the construction of E-MOSFET and also the working of E-MOSFET. Hope you understood well. After this, let me have some multiple choice questions for you which may appear for your entrance exams. Let me go for first question, that is, the MOSFET combines the area of dash and dash. I'm again repeating the question. The MOSFET combines the areas of dash and dash and dash. The options that is given are field effect and MOS technology. Option B is semiconductor and TTL. TTL means transistor logic. MOS, option C is MOS technology and CMOS technology, that is metal oxide semiconductor technology and CMOS technology, and option D is none of the mentioned. Let me check the answer. That is option A. The MOSFET combines the area of field effect and metal oxide semiconductor technology. The answer is A. Let me go for second question. The second question is choose the correct statement. That is options that are given is option A, MOSFET is a uncontrolled device. MOSFET is a uncontrolled device. Option B is MOSFET is a voltage controlled device. Option C is MOSFET is a current controlled device. Option D is MOSFET is a temperature controlled device. You all know that MOSFET is a voltage controlled device. Let me check the answer what it is. That is option B, MOSFET is a voltage controlled device. We have discussed when we are studying the MOSFET definition. MOSFET is a voltage controlled device. Let me go for next question. That is third question. The arrow on the symbol of MOSFET indicates, the options that are given is A, option A, it is a N-channel MOSFET. Option B, the direction of electrons. Option C, the direction of conventional current flow. Option D, it is a P-channel MOSFET. Let me check the answer. The option is B, that is the direction of electrons. When we are discussing the symbols of MOSFET, we have discussed that the arrow on the symbol of MOSFETs indicates the direction of electrons. Let me go for the next question. It is fourth question. E-MOSFET stands for, options that is given are option A, metal oxide selenium FET. Option B, metal oxide surface FET. Option C, enhancement metal oxide semiconductor FET. Option D, metal surface FET. We know that MOSFET means metal oxide semiconductor field effect transistor. E means enhancement mode metal oxide semiconductor FET. Let me check the answer. What it is? That is option C, metal oxide enhancement metal oxide semiconductor FET. The last question, that is fifth question. Which of the following terminals does not belongs to the MOSFET? Options that are given is option A, drain, option B, gate, option C, base, option D, source. We know that MOSFET is having three terminals, that is gate, drain and source. The base terminal which comes in BJT means bipolar junction transistor. In bipolar junction transistor, we are going to have three terminal: base, collector and emitter. In MOSFETs, we are going to have three terminal, that is gate, drain and source. Let me check the answer. What it is? Answer is option C, that is base terminal. This is a negative type question. Here you have to understand carefully which of the following terminals does not belongs to MOSFET. Here this base terminal is does not belongs to the MOSFET. Understood? This is all about the today's session. This is our team. Thank you, one and all. Thank you.